Welcome back to Applied Density Altitude, Sneaky Things numbers 2, 3, and 4. So, sneaky thing number 2 is that so far we've talked about being at standard pressure and standard temperature. But if you're taking off out of an airport that's at 6,000 foot above sea level, standard temperature is cold. Standard temperature at 6,000 feet is 3 degrees Celsius. And so what if it's only cool instead of cold? At 59 degrees Fahrenheit or 15 degrees Celsius, it would be what most people would consider a little bit chilly. You might have a windbreaker on, and as you walked out to the airplane, especially if you've been flying at sea level quite a bit, the idea that it might be a high density altitude day doesn't even cross your mind because it's cool out. Well, if it's warm out and you're at that 6,000 foot runway, say 85 degrees or 30 degrees Celsius, not atypical if you're up in the high desert mountains on a summer day, then your takeoff becomes very, very marginable under any circumstances. In fact, if I try to draw that to scale, the 50-foot obstacle is way off the end of the page out there at almost 3,000 feet. That's a half a mile away. Sneaky thing number 3 is the performance is predicated on a very specific technique and a brand new airplane or helicopter. Your pilot technique hopefully is good. That's why we practice short field and soft field takeoffs, is so that you know how to deal with this. But I know that you're probably not flying a brand new airplane or a helicopter. Even as you replace an engine at overhaul, over the next 2,000 hours or so, the performance of that engine slowly deteriorates, and it's still airworthy when they replace it, but it is not putting out the same power that it used to. With airplanes, as the propeller gets little nicks in it, they get filed out by the mechanics, and so the propellers become a little bit less efficient as time goes on. Airplanes and helicopters tend to have pieces of equipment added to them over time, and so they get heavier. So a lot of things can yield performance, actual performance, that is not what you see in the books. My recommendation is that you add at least 20% to the takeoff and climb out figures for airplanes in the general aviation business. When you get up into the airlines, it's a little bit different. But for GA airplanes, that pilot operating handbook takeoff stuff that's almost marketing material. I personally add 50% to ground roll and 50-foot clearance figures out of the POH. 50%, so 1.5 times what they publish. In addition to that, while your technique may be good, you learned it at sea level, and you need to do all of the things that are in the pilot operating handbook for your particular aircraft. That includes, for the 152, for instance, prior to takeoff from fields above 3,000 feet elevation, the mixture should be leaned to give maximum RPM in a full throttle static run-up. That's not something that a lot of instructors will have you practice down at sea level, because it's possible at sea level to actually overheat the engine a little bit. You don't have to worry about that above 3,000 feet as much. Even on a warm day, the amount of power that the engine is producing up there is so much less that it's okay to go ahead and run it up at full throttle and seek that absolute peak RPM. Having just an extra 25 RPM will make a big difference on your takeoff performance. Of course, helicopters are a little bit different. We don't necessarily lean helicopters at altitude. And so you need to talk to your flight instructor about what you do about that. You'll also need to pay attention to the wind a lot more when you're dealing with high density altitude. Operating with a tailwind and high density altitude at the same time is really asking for trouble. If you are in a spot where you can't take off into the wind because of an obstacle or for some other reason, then you really ought to think twice about doing it at all. You also have to take into account the surface of the runway. Quite often, if you're up in the high desert, you're operating out of a dirt or grass runway, and that has a big impact on getting off the ground. Predicting that is really problematic. We'll talk more about the 50-70 rule later. Sneaky thing number 4 is that your true airspeed is also affected. So you're used to climbing out at a certain indicated airspeed, and that is what you're supposed to do. You're not supposed to choose a different airspeed because of your altitude. That airspeed indicator represents the dynamic pressure that your wing and your propeller and everything else has to work with. And so it's important to keep that dynamic pressure constant, and so we use the same indicated airspeed each time. But we're moving faster than that. At a higher density altitude, instead of going 54 knots like we're used to when we practice climbing out at VX at sea level, we're actually traveling 60. That doesn't sound like much, but it's actually a little better than 10% faster. And you feel it. You become very sensitive to what your eyes pick up outside the cockpit. And so the temptation is going to be to raise the nose to slow down. And that is exactly what you have to avoid doing. That's it for this video, but please watch the next one, Applied DA 5 through 7, as we continue to look at some of those sneaky things that can get you into trouble at high density altitude.